so we're doing graphing systems of inequalities today. Inequalities. If you look at the system right there, how are inequalities different than what we did on Friday with equalities? How are they different? They don't have equal signs. They have less than, greater than, less than equal to, greater than equal to. So we're going to do this similar to the way we did it with equal signs. We are going to graph both of those lines. It's just, it's not just equal to. Like this one right here is greater than or equal to. So when it's greater than or equal to, it can equal the line, but then it's also greater than values. So we've got infinitely many answers. So does anybody remember what's going to happen when we have these? Anybody remember from previous courses? You remember shading? We're going to be shading today. But with the line itself, we are going to graph the line itself, but with this line, since it can be equal to, since there's a line under that greater than symbol, it is going to be a solid line when we graph it. But you look at the second equation, and this one is only greater than. It is not equal to. So the line is not something it equals. But we can't just have the shading without like a border where the shading stops. So we will put a line, but it's not really there. Does anybody remember what kind of line that is? That's there, but it's not there. It's the dashed line, right? So we'll put dashed here. Excellent. And then we look at these, and these are in standard form. So I'm going to find the x and y intercepts. You can change them out of standard form. You can put them into slope-intercept form, but you have to be careful if there's a negative sign in front of that y. Anybody remember what happens if you divide by a negative sign or if you multiply by a negative? What happens to the inequality? It's going to switch. So if you are changing the form and you forget that step, you might make mistakes. So I'm just going to leave it in standard form the way it's given to me and find my x-intercept. Been practicing finding the x-intercept, so I'm pretty fast at it now. My y-intercept is at 5, and my slope is at -2. And looking at that, I'm going to graph my y-intercept at 5, use my slope down 2/1. This is a solid line, so I'll use my straight edge and connect the line. Then from there, we have to figure out what region is shaded. This line divides the coordinate plane into 2 regions. We have to figure out which of the 2 regions is the shaded portion. So we're going to test a point. You can test any point you want as long as it's not on the line. So you get to choose any point you want as long as it's not on the line. Does anybody have a suggestion of a point that's easy to plug in, that's not on the line? 0, 0. You can do whatever one you want. I'm going to do 0, 0. So we'll test 2 times 0 plus 0 greater than or equal to 5. So 0 is greater than or equal to 5. And then is that true or false? That is false. That means that 0, 0 is not a solution. That means anything on the side that has 0, 0 is not a solution.
Do you plug the point into the top or the bottom equation?
Oh, it depends which one I'm testing. So right now I'm just doing the blue one. See, I'm like coordinating colors. So I'm just doing the top one.
See, because you're going to shade one side of it?
Yes. So later, when I graph the red one, then I'm going to retest that one too. Okay. So since it's the blue one and I tested it, it is not 0, 0, so I have to shade the other side of the line, but I'm not going to shade it super dark right now. I'm just going to kind of tell myself where it's going to be shaded in the future because I still have the other one to graph first before I shade in my final solution.
So you shade the side that it goes up, you shade the...
We shade the side that works. So if I'm not sure, I tested 0, 0, 0, 0 does not work. If I test any point on this other side, it should work. And if you're not sure, then test the point. But like you could test, what would be an easy one, like 4, 0. if I test 4, 0, you don't have to test multiple ones, but if I test 4, 0, I'll just do it to show you. 2 times 4, I probably shouldn't have picked that one, that's okay. 2 times 4 plus 0 greater than or equal to 5. 8 greater than or equal to 5. Yes, that one is true. So something on the other side worked. Okay. All right, the red one, I'm going to find my x-intercept at 2/3. My y-intercept is at -2. And my slope is +3. So I'll go graph my y-intercept and my slope. And it looks like 2/3 on the x-axis works. And this one is dashed. So we gotta shade it, or connect the line with a dashed line. Oops, that's not dashed. And then I have to test a point on the red line, or not on the red line, on the side. And 0, 0 is not on the red line, so I can test that one also. So I'll do 0, 0. 3 times 0 minus 0 greater than 2. So I have 0 is greater than 2. Is that true or false? 0 greater than 2? False. So that means I do not shade 0, 0. So I'll be shading this side away from 0, 0. Now there are infinitely many solutions. There are infinitely many solutions. I cannot write down one solution. There's so many of them. So my answer is the graph. So all I have to do is shade where both graphs overlap. And that will be my solution, is my picture. Because I cannot say one point that works. There's infinitely many. Every single point I'm shading right now works. It has a little triangle on top, only has blue. Right? So it's only where the two of them overlap. If you are working ahead, just make sure you are checking your answers as you go, because it's easy to make a silly mistake, and I don't want you to have the notes wrong and then use them later. So if you're working ahead, just make sure you're checking your answers as you go. So we are now on number 2. Example 2, we start out with y plus 4 greater than or equal to parenthesis x minus 2 quantity squared. What kind of graph is that one? It is a parabola. You knew that because x is squared. It's just not in the form that we're like normally see. So if I just take that 4 and I move it over to the other side, so I have minus 4. Now it looks like a parabola in that form that we've been seeing. And is there a stretch or a shrink on this parabola? No, there's only the translation of 2 to the right and then 4 down. So I'm just going to take my parent function, I'm going to go 2 to the right, 4 down, and just graph it there. So if you don't have your parent functions memorized, the sooner the better, because we're still using them. This one is a solid line because it's greater than or equal to, or is it less than or equal to? It's greater than, right? I'm sorry, I wasn't looking at it. Yep, greater than or equal to. So we need to test a point. What point can I test? 0, 0? No, because this graph passes through 0, 0. I've got to pick something else. So when you look at the equation, we're going to plug it in. By the way, plug it into the original. Do not plug it into the changed equation. Plug it in the original because you will make less mistakes that way. Trust me. Taught this before many times. Kind of old. Okay. I'm going to pick something that when I plug it in and then subtract 2 and then I have to square it, it's going to be a nice easy answer so I don't have to do a lot of work. Is there something I can plug in for x that is super easy to take away 2 and square? How about 2? Yeah. Plug in 2, and I'll just plug in 2, 0. I'll plug in that one right there. But you really can plug in any point you want. I'm just giving you tips of what I would plug in. So I'll have 0 plus 4 greater than or equal to 2 minus 2 squared. So I'll have 4 greater than or equal to 0. Ooh, that's true. So I will shade inside of the parabola. I'm not going to make it dark just yet. Yes, Jess.
So why did you have
You can, but like if you, for some reason, this is why I don't do that, because people will change it into like y equals mx plus b form and forget to switch the inequality when they divide by a negative sign, and if you use this one, you're going to have it shaded wrong, if you made a mistake. But if you use the original, you'll still get the shading right. That's why. But I see silly mistakes all the time, so I'm trying to help you not make those silly mistakes. So if you plug it into the original, you'll avoid some mistakes maybe. The second equation, what kind of figure do you think that is? Circle. It is a circle. We haven't learned how to do ovals, so it'll be a circle. And this one has 2 transformations, and I haven't showed you this transformation yet. So I'm giving you a hint by showing you it here. So when it was y plus 4 up here, and then we moved the 4 over so we could solve it for y, it went down 4. When it was y plus 4 originally, it went down 4. So here, where it's y plus 1, I'm not going to solve it for y. If it's y plus 1, what's the graph going to do here? It's going to go down. So when it's in parentheses squared, when it's a circle, it's going to be opposite. Even though it's the y, it's going to be opposite because it's not solved for y. So it's going to be opposite. The x is still opposite. That one's going to be right 3. So we'll go right 3, down 1. That's going to be the center. And then our radius is what? 6. You take 36 and square root it. So from the center, go out 6. And do your best to draw a good circle. We have to test a point. Oh, I'm sorry. It's solid line because it's equal to, greater than or equal to, or less than equal to. We have to test a point. What point would you suggest we test? 0, 0 is fine. That's usually my my plan unless I can't use it. So we'll do 0 minus 3, negative 3 squared plus 1 squared less than equal to 36. So that gives me 10 less than equal to 36, which is true. So we shade inside of the circle. So what you have to find is where they overlap. Inside the circle, above the parabola, is going to be like this. So our solution is where the 2 graphs overlap.
You say you plugged in 0, 0?
Yeah. I did like 0. I did 0 minus 3,
Okay.
which is negative 3 squared. Okay. The next one has a line. You guys, if you're working ahead, should be able to graph that line. Start. It's in standard form, so I'm going to find x and y intercepts. You could change it into the other form if you want. X-intercept is 6. My y-intercept is 5. And this is a solid line because it has the line underneath the less than symbol. We have to test a point. I'm going to test 0, 0. Looks easy. So 5 times 0 plus 6 times 0 less than or equal to 30. 0 less than or equal to 30. True. So we'll shade this side of the line towards 0, 0. Now the next equation, y is between 0 and 30. This is actually two equations or inequalities. It's two of them. It's that y is greater than or equal to 0 and y is less than or equal to 3. That's what's it called when they go together? What's it called in English when you have like do not and then don't? A what? No. What is it? That's not the word I'm looking for either, but it's kind of like that. Do not, and then you put it together and they don't.
Yeah.
I can't remember what it's called. But anyway, it's something like that, where it's like two equations, but you put them in one. Like the same thing. Anyway, so we've got two lines. We've got one at... What? Okay, we got one at y equals 0 and one at y is 3, and then it's in between those two numbers. So y by itself is like the horizontal line. So we have a horizontal line at y equals 0, horizontal line at y equals 3, and then shade in between them. So it's in between those two lines. And then the x is the same way. There's two of them. There's x is greater than or equal to 0, and x is less than or equal to 4. And it's everything in between 0 and 4, but x is always vertical. And then we're going to shade in between. But your goal is to find where all of them overlap. To find where all of them overlap. And that's this figure. Now there's more directions, by the way. We're not done with the directions. It says graph, and then it says find all the coordinates of any vertices form. Find the coordinates of any vertices form. So we formed a, what is that geometric figure?
I have a quick question.
Yeah.
So do we always shade inside the two lines?
If it's set up with the variable in between two numbers, then yes. Okay, it's not a triangle. What is it?
Trapezoid.
The part I colored.
Oh, I thought you were talking about.
Not a trapezoid because there's not four sides. Who taught you geometry?
I saw 4 sides. I think you did.
I know, that's why I said that. It was me. 5 sides, pentagon, pentagon. So how many vertices are there for a pentagon? So we have to write down 5 vertices. So 0, 0, that's one of them. 0, 3. 4, 0. What else? They're fractions.
Oh,
So, we're going to find them. It's not going to be that bad. We're going to use our brains here just a little bit, let's look at this vertice. Let's look at that vertice. That vertice is the intersection of two lines. It's the intersection of my blue one, which is the first equation, and this red one, which is y equals 3. So that ordered pair has to be something 3. It has to be. It's sitting on the line where y is 3. So if I know that the y is 3 and it's on this blue line, then it has to work in this blue equation. It has to work in that first equation, and y has to be 3. So I'm going to put in y equals 3. 5x plus 6 times 3. And I'm just going to use equals because I want to know what it equals at that point. I don't care about the shading for a moment. So I'll have 5x plus 18 equals 30. And I'm going to solve that, take away my 18, and divide by 5, and I get 12 fifths. So my ordered pair, x is 12 fifths when y is 3. So I had to do a little bit of algebra, a little bit. Substitution. There's this other point that has the same problem. It is a fraction, telling you that it is a fraction, but it is sitting on this green line. And what's the equation of that green line? X equals 4. So I know that that ordered pair is 4 comma something. So it is also on the blue line. So if I put 4 into the blue equation for x, then I can find y. 5 times 4 plus 6y equals 30. So 20 plus 6y equals 30. 6y is 10. Divide by 6, reduce it, 5 thirds. So we have all 5 vertices. Almost done. On the back. Turn me back. Turn me back when you're ready to go on. The last ones are just, they've already shaded it, and you have to find the equations. So it should be pretty easy to find the equation of a line. I would just put it into slope-intercept form. This form. So what is our slope? Rise over run. What's our slope? So -1 is our slope. It's -1, so I will write -1x or just negative x.
Wait, is that you're just plotting 0, 0? Is that what that's on?
Yeah, 0, 0 is like testing a point. It's not on the line. It's not on the line. Okay, and then what is our y-intercept? 1. And then we have to figure out what side it is shaded. So you could test a point, I don't know, 0, 0. And figure out what sign has to go in here, in this little spot here. What sign to make that true? It's got to be less than. And then we say, is it dashed line or is it solid line? It's dash, so it's only less than, not equal to. Here's something else. If it is a line, if it is solved for y, you can also use, is it above or below the line? If it's below the line, it's going to be less than. So that would be another way of figuring that one out, besides testing it. Okay, this one is a circle. Center is at 0, 0. Circle equation, x squared plus y squared equals r squared. So we're going to have x squared plus y squared. And then what's the radius? 3, so we'll put 9. And we just need to test a point, I don't know, 0, 0, to see if it is less than or greater than. Which one makes it true? Less than makes it true, but this one's going to be less than equal to, because it's solid.
So the answer to 0 is less than or equal to 9?
No, the answer is the equation.
Oh.
This was me testing the ordered pair 0, 0 to see if it's greater than or less than. To see if it lines up with what she did. Yes, Renee?
How do you find out that it was plus 1 in the other?
That was the y-intercept. Oh my god, I said that. I'm not trying to make the equations too difficult. Just can you find the equation and know what sign it is? This one's a little bit more challenging. I put 1 through 4 so we could kind of coordinate the equations with what we were talking about over there. And then I'll help you with them. Number 1 is that vertical line. So I know it's like x equals, but there's 2 for number 1 that you can't really see. X, it's less than 5, but it doesn't go all the way less than 5. It stops here at 0. So the first one's going to be 0 less than or equal to x less than or equal to 5. Because it doesn't just start at 5 and go all the way. It stops at 0. And then the second one, number 2, is y, and y is equal to 5 up here, but it doesn't go all the way down. It stops at 0 again. So the second one's going to be y is in between 5 and 0. So we had some like this where we graphed, and now I'm showing you them backwards, where you find the equations. The third one is a line. I'm just going to find my slope and my y-intercept. So my slope, if I count down 2 over 2, is -1, so negative x. And then my y-intercept is off the graph, but it's not that far. I can just follow the slope and find that it is at 8. If you can't find the y-intercept, you can also use point-slope form, which we did in chapter 1. So you can use point-slope form to find it. And then, is it shaded above or below this line? Is it shaded above or below the line? Shaded below, so we will do less than equal to. And then the last one is shaded below the line. The slope is up 3 over 1, so 3, and the y-intercept is at 0.
That means below the line, if it's right?
There's no right or left. Since it's y equals, we think up and down only. But if you're not sure, just test the point instead. Like, plug in 1, 1. And if I plug in 1, 1, 1 less than or equal to 3, like that one's true. So you can test the point too. All right, and the last one, we've got a line and a parabola. The line is shaded above it. It's shaded above the line. So it's going to be y is greater than or equal to. Slope is -1/3. Y-intercept is 2. And then the parabola does not have any stretch, just has a translation down to. And it is shaded above it, so greater than or equal to. So for your homework, you're going to do a bunch where you have to look at the graph and write the equations, and then you'll do like 5 graphs, and I have graph paper for that. It is in the book, so if you didn't bring a book today, because I didn't tell you to, if you didn't bring a book today, I have lots of them that you can borrow. If you'd like to take a picture of it and have it on your phone, that's fine. If you want to go on Canvas, I put the book on the calendar, but the shading doesn't show up. So you can get everything except for the shading on the book, because it's in a black and white on Canvas, and it's in color in the book. It doesn't show up. Very not good at big copy.
And it's just going to make it flat. That's how it usually does it.
This is not a very good book. It doesn't, no, whoever uses our scanners don't work very well. And I'm not about to scan the entire book on my phone, so.
Because like usually if you print something else, it's like a color, like a.
Right, it looks
make
like a
black.
grayscale.
Yeah.
It didn't even show up at all. So, the graphs are for 33 to 43 is the graphing part, so I gave you graph paper for that. The rest of it you'll just have to put on your own, paper, or fit it in somewhere. But I have lots of books that you can borrow, just put it back. If you don't have a book checked out yet, and you would like to check one out, I have a list.
This book good.
Yeah. I don't know why.
I had an extra paper. I thought it was like a package.